Collagen is the most abundant protein within the human body, and from skin up to brain we have collagen everywhere, so that we need it to mimic the in vivo situation. The role of collagen even in vitro cultures is very special, because we need an extracellular matrix protein to mimic the in vivo situation, so that cells behave like within the human body to express normal proteins and different other things. If you use a well plate without any substrate, you just have the plastic. It might be a very good control. You need a good substrate to mimic the in vivo microenvironment, and that's why I suggest always to use at least an extracellular matrix protein, and collagen is very important. If you want to have high quality results that are always at the same stage of quality, then you need a system that gives you at least homogeneous results. You have to choose the collagen that is even in the implantation site or in the site you want to analyze. For example, if you want to analyze the tissue reaction to a bone substitute, you should use maybe collagen type 1 at most, because it is the most abundant collagen in bone. I'm using collagen type 1. I'm analyzing the reactions to bone substitutes, but I also try or test and develop different scaffolds based on collagen in vivo for different applications, mainly for bone regeneration and also for soft tissue regeneration. Also for bone regeneration, I analyze mostly collagen type 1 scaffolds. I'm very interested in the tissue regeneration, and especially in bone tissue regeneration. And we already analyzed the tissue reaction to pure collagen or jellyfish collagen scaffolds. My interest is in combining it, for example, with bone substitutes. There are different products already on the market, but I think the homogeneous quality of this collagen is very suitable even for production of scaffolds made of the jellyfish collagen and different bone substitutes. And I'm very interested in 3D printing, even because of the very good melting point. Jellyfish collagen is optimally suitable for 3D printing, different 3D printing techniques. I'm not the biggest fan of synthetic collagen, because I think there's a big problem even in the context of the analysis of inflammatory reactions. And I already tested red tail collagen, and it was also not suitable for my analysis. And I'm not the biggest fan of porcine or bovine collagen, even because there's no homogeneous quality of the collagen. That's my big problem. And that's why I'm working now with jellyfish collagen, and I'm very happy. I analyzed the tissue reaction to biomaterials at least with many different systems based on a pig or bovine collagen, and we have different problems at least with the quality of the collagen. There are different options to extract collagen, and if you, for example, if you extract it from porcine skin, there are very big differences in the quality or in the length of the different fibrils of collagen, and so you have no real homogeneous system for testing in vitro the tissue reactions. It is very, very important to use collagen that has always the same quality. I'm working in the field of the development and testing of different biomaterials or medical devices. At first, we need good test systems, even in the context of the new medical device regulation but we also need very good and very interesting new biomaterials. Jellyfish collagen is very suitable for very different applications and indications in the future. We have different problems with the actual collagens, even because of BSE. I think collagen is one very enormous chance for the future of biomaterials. The future of the in vitro analysis is to mimic the complex situation within the body, so that we don't need any further animal experiments. Before we have to test different things, but for all of these test settings, we need collagen as a scaffold to mimic the extracellular matrix perfectly. In maybe 10 years, we will have a lot of different 3D printing medical devices, and I hope we can produce nice patient individual scaffolds, and we don't have to use, for example, granules and different other materials that are still on the market. 3D printing will be the future for the development of materials for nearly every application. A biomaterial is needed. If we can print directly within the clinic or directly within the practice a cheap material, then we can help a lot of people in the future. And that's for me my personal goal, to develop a cheap but very good biomaterial that we can print chairside.